Hello teachers, you are most welcome in this online session. So as you know, we are doing this, our unit number 1, which is complex numbers. So I'm here as your mathematics teacher. Now, as you know, last time when you were here at school, we discussed about different concepts about these complex numbers. By revising, please, you must know the concept of those complex numbers. We have seen that this complex number, this set C, it is made up of A plus BI, where A and B are the set of all real number, not only this one, but also it is an element I square, which is equal to negative 1. Then we can also have a form. We have different forms of a complex number Z. Then in the algebraic form of this complex number Z, it is written as A plus BI. And you know that you can write BI or IB, and so on and so forth. Not only this one, and also you have to revise about the properties of I. So please you have to remind yourselves about these properties of I. And also you have to revise the representation of complex number Z in the Argand plane. After representing those Z in Argand plane, you have also to deal with what we call an operations. Please revise those operations on complex numbers. In complex number. Then after, you have to remind yourself where you have addition, subtraction, multiplication, even division. And also you have to add something which is called the conjugate of a complex number Z. For example, this complex number Z, which is A plus BI, is conjugate. If you remember, we denote it as Z bar and it is equal to A minus BI. That is about what you have to revise. And also, not only this one, but also you have to revise the modulus of complex number. Z. You have seen that where you have a Z which is equal to A plus BI. Its modulus, it is equal to A squared plus B squared. Then you will find its a square root. That is what you have to revise. Then after revising those ones, what we are going to focus on, it is most we are going to require what we call a square root of a square root of complex number Z. This number Z. I hope that you remember to find the square root of the complex number Z. If Z is equal to A plus BI, and it find its square root. Z square root, you can say that is X plus Y I. And I hope that you are able to find this X and Y. So after those concepts we talked about while you are here at school, we can even talk about solving equations in a set of complex numbers. So to solve those equations in a set of complex number, we solve around the two equations. So what are them? As we solve in a set of all real numbers, in a set of all real number, we use it to solve a linear equation. We solve also quadratic. I hope you remember quadratic equations. Now, if you remember, ax plus b, which is equal to 0, it's the same. In this case, expression which is ax plus b, which is equal to 0, we find the value of x that satisfies this expression to be equal to 0. It means we find the value of x that satisfies this equation to be equal to 0, and we say that this x is negative b over a, and you write the solution of this kind of equation. Then how about those equations in a set of a complex number? How to solve them? We haven't talked about it. Even in the quadratic, we say that we have the form ax squared plus bx plus c is equal to 0. And this kind of equation in the set of all real number, we use different methods to find the solution of this equation, where you can use factorization, you can use completing squares, you can use determinant formula, you can use quadratic formula, you can even use factorization and the other methods you normally use to solve those equations. Now, in a set of complex number for linear equation, for example, linear equation, we can see how to solve this linear equation. It is of the form ax, az, we use az plus b, which is equal to 0. In this case, we find the value of this z that satisfies this expression to be equal to 0. What does this mean? Here it means that az plus b is equal to 0. We find the value of this z where this expression will be equal to 0. This implies that it's equal to az is equal to negative b, while this we have found that implies that z is equal to negative b over a. And you can write the solution in that case, and you say that's negative b over a. Now, we can solve some examples about this kind of linear equation in a set of or a complex in a set of complex numbers. Let's see how to solve those kind of equation. For example, examples. Let's say, for example, we have to find the value of z if for z plus 5I is equal to 12 plus I or minus I. This solution for this question, please follow how to find it. It is what is required is to find the value of this z that satisfies this expression to be equal to this one. How? Now, what is the value of this z? Here, for given solution, we have a 4z plus 5I, which is equal to 12 minus I. This is equal to what? We need to find this value of this value z. It means you have 4z, it will be equal to, here there is no other variable because the variable is z. We can take this one to this side. Then you have a 12 minus I, then minus 5I. Now, we say that z will be equal to 12 minus 6I, then over this 4. And we can say that our z will be equal, we can simplify to have a 3 plus minus 3 over 2I, like that. And this is the value of z. Now we can do another question to find the value of z. Find the value of z if negative 1 plus I is equal to I plus 2, then times z. What's the solution for this kind of equation? To find the value of this one, you can have a solution. Let's solve this one. We have a negative 1 plus I, which is equal to, here multiply z, you have a zi plus 2z, but you can find this one without multiplying. We have a I plus 2I, then z, then this implies that z should be equal to, because we are finding the value of z, this is negative 1 plus I over 2 plus I. And in this case, if you remember, we cannot have this kind of z. We have to find the exact value of z in forms of algebraic form. In its algebraic form, where you have a z which is equal to negative 1 plus I over 2 plus I, you have to multiply its conjugate. Here, you multiply its conjugate of this denominator, where you have 2 minus I over 2 minus I. Finally, if you solve this clearly, you will find that is negative 1 plus 3I over 5. And this is its value of our z. So that is about the linear equations. We can even solve in the exercise. Please solve this one. Find the value of z if z plus 1, 3 is equal to 4 plus I. That's the question I have to do. Then after solving this linear equation, we can even solve quadratic equation. So for the quadratic equation, we have, if you remember, it is of the form ax squared. In this case, we use z. Az squared plus bz plus c, which is equal to 0. Now, to solve this one, to solve the az squared plus bz plus c, which is equal to 0, it requires some expressions to follow. For solving this expression, there is two cases you have to follow. For example, for the case, and remember that z in this form when a is different from 0 to be a quadratic. Now for az squared plus bz plus c, which is equal to 0, and a is different from 0, and b is equal to 0. When b is equal to 0, you can solve this kind of equation where you can say that now we have az squared plus z, which is equal to 0. Now to solve this one, it is the same as to find the value of z. The value of z, here I will say that it will be equal to z squared will be equal to negative c over a, and this case implies that z will be equal to negative c over a square root. And this negative, there is no problem because you normally know that I squared is equal to negative 1. Now, let's say, for example, for example, you can solve z squared plus 1, which is equal to 0, then you find the solution. Let's say, for example, solve in set of complex number. So in set of complex number, to solve 1, z squared plus 1, which is equal to 0. In this case, you can find the solution. Now, the solution for this case, we normally know that we can find the solution where we know that z squared is equal to this one on that side, it will be equal to negative 1. And then we have a z, which is equal to square root of negative 1. And we know that square root of negative 1 is equal to I square. We can replace this one by plus or minus I square. And we find that our z will be equal to plus or minus I. Then solution, we say that our solution will be plus or minus I. That is the solution for the first equation where we are requested to find the value of z in the set of the complex number, and also in the case where we have the coefficient of x is equal to 0. You can have even more than this one, but this is a sample. And also, for example, let's do the second one. We have 2z squared plus 8 is equal to 0. Let's say solve and we see the complex number 2z squared plus 8 which is equal to 0. In this case, you can find the value of z that satisfies this expression. That is means solution. This implies that we have a 2z squared plus 8 which is equal to 0, and this is equivalent to 2. We have a 2z squared is equal to negative 8, and if it is equal to negative 8, please, you know that you can divide both, then you will make with 2x squared, z squared, which is equal to negative 4. And finally, you say that our z will be equal to square root of negative 4. Then we can remove this negative by saying that z is equal to 4i squared. And then finally you say that z is equal to 2i plus or minus 2i. Then you write the solution as plus or minus 2i. That is for the case of this quadratic equation in where the coefficient of our our x is equal to 0. Now, for the case of az squared plus bz plus c which is equal to 0, a is different from 0 and b is different from 0, we use the way of finding the quadratic formula. And the quadratic formula, you normally know that it is written as determinant and it is b squared minus 4a ac. And then, when we are solving this kind of equation, we have to know that not when we solve and find this determinant. For example, if determinant is greater than 0, in this case we have two distinct real roots. And in the case where if determinant is equal to 0, in this case you have one real root. And then if determinant is negative, in this case we cannot say that it's not possible or no solution because we have two complex roots. Now we are going to solve. Please, if you are solving a quadratic equation and you find determinant and you find that it is greater than 0, it means it is positive. Now we are going to find it's two. We are going to have two distinct real roots. And if determinant is equal to 0, we are going to have one real root. And if you find it is negative, you are not going to say that there is no solution. In that case, there is a solution where we are going to have two complex roots. Let's see, for example, where this case is possible. Examples solve in a complex number, in a set of complex number 1 z squared plus z plus 1 which is equal to 0. Now, to solve this one, first you have to find the determinant. The determinant is b squared minus 4ac. Now you have to identify which is a, which is b, which is c. From this one equation, a is equal to 1, coefficient of z squared, and b is equal to 1, coefficient of z, and c is equal to 1 also. Now, determinant is equal to what? It is equal to b squared. B squared is 1 square, then minus 4ac. AC is 1 times 1. Then final determinant will be equal to 1 minus 4. Then determinant will be equal to negative 3. Then we normally use it to find the square root of determinant. In this case, will be the square root of 3, negative 3, and negative 3 doesn't have a meaning. You have to multiply I squared. And we say that our now if the square root of determinant will be equal to square root of 3, then I. Now after finding the square root of determinant, we normally know we can find z. We can say that z is equal to minus b, negative b is negative 1 plus or minus square root of determinant, which is square. This is square root of 3 over 2, and 2 is a is equal to 1. And if a is equal to 1, we multiply 2. Now we find that our z1 is equal to negative 1 plus root of 3I over 2, and z2 is equal to negative 1 negative square root of 3I over 2. Then we write the solutions. Solution, it will include negative 1 negative 3 square root of 3I over 2, and the root be negative 1 plus root of 3I over 2. That is the question. The solution of the question we asked you to find its solution. Now, another question you can solve. Let's say, for example, if we are asked to find the solution of this equation in a set of complex numbers. What does this mean? Let's solve, for example, question number 2. Let's say z squared plus z plus 3, and this is equal to 0. In this case, when you have this kind of equation, you have to solve in a set of complex number. Now, solution of this question, you have solution for this question, it will be, we have to identify, you have z squared plus z plus 3, which is equal to 0. We have to identify which is A, which is B, which is C. Now, A is equal to 1, B is equal to 1, and C is equal to 3. Now, if you find that A is equal to 1, B is equal to 1, and C is equal to 3, we can find the determinant. Where you say that determinant is equal to B squared, which is equal to 1 minus 4. A is 1, then you multiply C, which is 3. Then for this case, you find that the determinant will be equal to 1 minus this times this 1 is 12. So we have a 12, and the determinant will be equal to negative 11. And you find that the determinant is negative 11, and we normally know how to find the square root of this determinant. The square root of this one will be equal to 11I squared d, then square root, and you say that determinant square root is equal to 11 square root of I, then I. Finally, z will be equal to negative b, which is 1, is negative 1 plus or minus root of 11 I over A is 1, it means it is 2. Now a solution will be equal to, it is, let's write this one as this plus or minus square root of 11 I over 2. That's the final solutions for those kind of equations. You have to solve a set of all complex numbers. That is all. So, let's give you a question in the exercise that you have to solve. Then finally we shall meet in the next time. Please solve in the exercise the equation 1. Solve in a set of complex number. It is one equation is enough. Z squared minus IZ, which is equal to 4 plus 2I. So you have to solve this kind of equation, then you find the solutions. Now wait, for these equations, please, I want you to focus on. Sometimes you can find the determinant and you find that it is in the form of A plus BI. And if you find that it is in the form of A plus BI, you have to find the square root as we use to find the square root of a complex number Z. As you know, A plus BI and Z, the square root of Z, you know how to find it. It means it is x plus yi. And you remember to find this x and you find this y. So please, if you are doing the exercises and you meet with this challenge, please make sure that the square root of this number is the square root of a complex number, not a real number. Find it as you use the formula to find it. The square root of the complex number. So see you. We shall continue next time when you get a chance. See you. Thank you very much.